Okay, in this example we have this collar right here, C, which is moving down along this bar at 2 meters per second. C is connected to this point B with this link, and B is connected to point A with this link. And we're asked to figure out the angular velocity of this bar and the angular velocity of this bar. So if we get this problem, we notice that what we know the most about this bar right here, we have a velocity of C. We'll probably have to determine a velocity of B and this angular velocity. But we don't know anything right now about this link right here, AB. So let's look at link CB first. And one thing we know this is rotating and translating, so this is going to be general planar motion. And I want to draw my kinematic diagram that's going to show all my velocities and position vectors and everything. I like to do that. It helps me keep it organized when I'm working through a problem. So general planar motion. So with this link CB right here, we know that we have a velocity C, which is acting straight down. This velocity C, it's constrained along this collar is constrained along this bar. So VC is perfectly vertical. And at this position right here, B and A are lined up perfectly. So the path B is taking is this sort of circular path. I know it doesn't quite look circular, but it's right at this point right here. So the velocity of B is going to be only in the horizontal direction. So this point B right here is only going to be in the horizontal direction. So we have a VB in this direction. And we don't know what it is, so we're just going to call it a VB of I. And we do know what this velocity of C is. We know it's 2 meters per second, so it's in the downward direction. It's going to be a minus 2j. One equation that we typically use when we're finding relative velocities, and we're using the vector type of we're solving it in a vectors notations. We have a velocity of B, which is equal to the velocity of C plus omega of this BC, this link BC, cross with the position vector B with respect to C. Now what I like to do, I like to just write out everything I know, just to figure out what I need to solve for or assume. And we have a VB here, so this is a VBI. Our next term is a VC. VC is equal to minus 2j. This omega BC, we're asked to find what this is. So omega BC is we're going to assume it's a positive angular velocity. So it's going to be omega BC with a k component. And this position vector of B with respect to C. So we start at point C. We go to point B, and that's this position vector R of B with respect to C. And to get to C, we need to go down 0.2 meters and over to the right 0.2 meters. So we have sort of something like this, down and over. And in order to do that, this is going to be, I like to keep my I components first when I remember. So 0.2i minus 0.2j. And now I have all the parts of this equation, and I can just substitute in. So I have a VB with an I component is equal to this minus 2j plus this omega BC, which is a k component, crossed with the 0.2i minus 0.2j. So when we perform this cross product, I like to always draw out this little circle helps me figure out what's what so I don't make a mistake. This way is my positive, this way is my negative. So if I have when we look at this cross product, we have a omega, we're going to do this k with this I, and then we're going to take the cross product of this k with this j. And we can take the scalars out in front, so we get, so this one becomes 0.2 omega BC, and it's a k cross an I, so a k cross an I is a positive j. And right here we're going to have a minus a 0.2 omega BC, and this is a k cross a j. A k cross a j is a minus I, so this actually becomes a plus sign, and we have an I component. And if we bring down this part of the equation, we have a minus 2j, a plus, and is equal to VB with an I component. So now we just want to equate our I terms and our j terms. So if we look at our I terms, we have VB on this side of the equation is equal to this 0.2 omega BC. We don't know, we have two unknowns, one equation right now, so that's not good. So let's look at our j terms. We have a 0, which is equal to minus 2 plus 0.2 omega BC. And when we solve for omega BC, we're going to get omega BC is equal to 10 radians per second. And our assumption is true. It's a positive, so it's moving counterclockwise. So now we can plug this omega BC right back into this equation right here. This is going to be a 0.2 times a 10. So we have a velocity of b, which is equal to 2 meters per second, and it's moving towards the right. Okay, so we figured out this part of the problem, and now we have to figure out what the angular velocity of bar A is. So if we draw, again, a kinematic drawing of this link A, we notice that this is a rotation about a fixed axis. And this means that point A is never moving, it's just fixed. But we do have the velocity of point B. Point B is going to be moving to the right at 2 meters per second. And let's look at the equation for a rotation about a fixed axis. We have a velocity of b is going to be equal to this omega AB crossed with the position vector, or the distance, the position vector b is away from the fixed axis. So right here, that's just going to be this distance. So again, I don't really want to jump ahead, so I'll just do this out sort of in order. My VB is equal to 2I, right? It's moving in the positive I direction. My omega AB is unknown, so I'm going to assume it's positive, and it has a positive k component. And this RB is this distance starting from the fixed axis to the point we're looking at, and RB is going to be down 0.2 meters, so minus 0.2 j, because we have to go from here to here. Okay, so if we plug in everything we know, we have 2I is equal to omega ABK crossed with this minus 0.2j. And to do this cross product, we have a minus 0.2 omega AB with a k cross aj. A k cross aj is a minus I, so this becomes a plus sign. And we have 2I is equal to 0.2 omega AB. Now, if we only have I components, so we can just sort of equate this to each other. We have 2, which is equal to 0.2 omega AB. And we can solve for the angular velocity of this link AB, and we get that it is equal to 10 radians per second. And again, our assumption that it's positive is correct, and it's really moving in the counterclockwise direction.